students, so far we have used factorization method while finding the roots of the quadratic equation. Now we will discuss here the another method, that's completing the square method. This method is also used for finding the roots of the quadratic equation. So I have posed here the question, what is completing the square? First we will try to understand this completing the square. What does it mean? I will take an example of a simple expression x square plus bx. Now with the help of geometry I will express this x square in this figure. See on the figure, this is square shaped diagram, or we can say it is a square whose area is x square. The side of square is x and its area is x square. Then here is plus, and I have constructed this figure to represent the bx. See, this side is the x and this side is b. So the expression x square plus bx is represented in this figure like this. You can see this square shaped figure and this rectangle shaped figure, and in these two, this side is x, this side is b, this side is x here. Now coming to the next step, here I will take this square here and I will not make any change in this figure. Now see here, this bx, I will break or I will divide this figure into two equal parts such that the length of each part is x and breadth of each part will be b by 2 and b by 2. So we have two parts now of this figure. Now I will take one part of this figure and will keep on the right side of this square, and will take second part and will keep down here, down the square. Here its breadth is b by 2 and length is same, that's x. Here its breadth is b by 2 and length is same, that is x. Now combining these two figures, these all figures, we will come to the next step. See here, once I will combine these two, this figure and this, so this x will get added to this b by 2, so this side will become now x plus b by 2. And same is the case here, when I will bring this side, this figure close to this side will become equal to x plus b by 2, that's here, x plus b by 2. Now in this diagram I have two sides, this side is x plus b by 2, this side is x plus b by 2. Now look at this side, this is only from here to here, it is only x, and look at this side, from here to here it's only x. Now I need this side, it should be equal to x plus b by 2, so that, and this side also, this needs to be equal to x plus b by 2, so that this whole diagram will become a complete square. All the sides will have the same measurement, we can say x plus b by 2. For that purpose I need to add here b by 2, so that this side will become x plus b by 2, and here also I need to add b by 2, so that this whole side will become x plus b by 2. If I will add, it means I need to add a small square, b by 2 into b by 2, that is b by 2 whole square. It will become a complete square. Now look at here, all the sides will have the same measurement, that's x plus b by 2, and the area of this square can be represented, can be expressed as x plus b by 2 whole square. So in this way we can see a x square plus bx, we have completed the square, since it was not here the square, complete square. Now here by adding b by 2 whole square, it has been formed now the complete square, that's x plus b by 2 whole square. So we can say in general, to make expression x square plus bx complete square, we need to add b by 2 whole square. And algebraically we can say x square plus bx plus b by 2 whole square equals to x plus b by 2 whole square. You can also see, if you will use the formula a plus b whole square equal to a square plus 2ab plus b square, if you will use this formula and you will elaborate this according to this formula, then you will get the result, this result. So here, to make the expression x square plus bx complete square, what we did, we added b by 2 whole square. So what is the need to make an expression a complete square, that we will try to understand. In other words, what is the scope of this completing the square? That is, here we have x square plus bx plus b by 2 whole square. This we added, b by 2 whole square, this we added here. And this was the expression, and we got this expression x plus b by 2 whole square. You can see here there are two terms containing the x. So x is twice here. Here in this term there is x, and here in this term there is x. And instead of this, you can see here the x is only once. So here x is in two terms. Here only x is once. Only one term contains the x, or we can say only x is once. So it makes us very easy to solve this. That's why we are doing completing the square. We are completing the square. That is about it. Now look at this example, x square plus 6x plus 7. This is in the form of ax square plus bx plus c. When we compare this expression to this general form, so we can see here the coefficient of x is b, and the coefficient of x here in this expression is 6. So we can, on comparison, we can say b is equal to 6. So b by 2 whole square will be 6 by 2 whole square. 6 by 2 is 3, because 2 ones are 2, 2 threes are 6. It is 3 square. So see here, now we will make this expression a complete square. How? I will write here x square plus 6x, then I will add b by 2 whole square, that I explained before what we are doing in completing the square. B by 2 whole square is 3 square actually here. So I will add 3 square plus 7 and minus 3 square. Why I am doing subtraction? Adding this minus 3 square, in order to make this expression balance. Because if we will add 3 square, this only we will add 3 square, it will not remain the same. If we will add, we have to also subtract it, so that it will remain the same expression. So instead of these 3, x square plus 6x plus 3 square, I can write x plus 3 whole square. How? You can use this formula, a plus b whole square equals to x square a square plus 2ab plus b square. See here, a square 2ab b square. I can write from this, I can write a plus b whole square. It is same like that, a square plus 2ab plus b square. I can write a plus b whole square. In place of a it's x, in place of b it's 3 plus 7, and minus 3 3s are 9. Then x plus 3 whole square, 7 minus 9, it's minus 2. Now look at this, x square plus 6x plus 7 can be written as x plus 3 whole square minus 2. The both expressions are same. They both have the same values. See here in this expression, the x is written twice. 2 times it is written. In this expression, here is x. In this expression, here is x. And here in this whole expression, x is only once written. So it makes it easy to solve. Now we will try to understand how can we use completing the square method while finding the solution of the quadratic equation or while finding the roots of the quadratic equation. What are the steps that needs to be followed? The first step is make coefficient of x square unity. It means every quadratic equation will have the term that contains x square. We should make that its coefficient unity. Unity means 1. Suppose if the coefficient of x square is not 1, then what we should do? By dividing the equation with coefficient of x square, we should divide that equation, each term of that equation on both sides with the coefficient of x square. Then we can make the coefficient of x square as unity. We will explain it while solving the questions. And the second step is take constant term to RHS, that's right hand side. We should take the constant term to the right hand side. And next step is add b by 2 whole square or 1 by 2 coefficient of x whole square on both sides of the equation. It means we should see in equation b by 2 whole square or half of the coefficient of x whole square and should add on both sides of the equation. The fourth step is take square roots on both sides of equations. We can take square roots of equations because we will have on LHS we will have the term, the expression having whole square. We need to remove that square. Because of that we should take the root. We will explain it here in the questions. While solving the exercise we can understand it better. Fifth one is simplify and find values of x. Then we should follow the simplification and should find the values of x. Now look at the exercise 4.2 question number 1. Sorry, 4.3 question number 1. That is find the roots of the quadratic equation if they exist by the method of completing the square. The first part is 2x square minus 7x plus 3 equal to 0. This is the first equation. First part. See here we can solve it by using factorization method, but here the question is asking to solve it by using the completing the square method. So we have to use strictly this method, that's completing the square method. See here the first step, as I told you before starting this exercise, we should make the coefficient of x square unity, that's 1. Here the coefficient of x square is 2, so I need to make it 1. What I will do, I will divide each term of the equation on both sides with 2. So what I will write, 2x square by 2 minus 7 by 2x plus 3 by 2 is equal to 0 by 2. What I did, dividing each term by 2 on both sides. Why I will divide only the 2? Because here the coefficient of x square is 2. If it was 3, then I would have divided 3. If it was 5, then I would have divided with 5. It depends on here what is the coefficient of x square. So in the next step, what we will get here, 2 cancel. Here we will get x square minus 7 by 2x plus 3 by 2 equal to 0. What is the next step? That is x square minus 7 by 2x. We should take this or transpose this constant term to the right hand side. That is it will become minus 3 by 2. Then the next step is add 1 by 2 into coefficient of x whole square. Remember step by step what I am doing, understand it carefully. So 1 by 2 coefficient of x. So first I should write 1 by 2 into what is the coefficient of x, that's minus 72 whole square. Minus 1 into minus 7, it's minus 7, 2 into 2, it's 4, minus 7 by 4 whole square. Since I can write it 7 by 4 whole square. How I can? Because if you will expand it, you will write it in a simple form, you will get minus 7 into minus 7, that's 49 by 16. Here also you will get 7 into 7, that's 49 by 15, because minus 7 into minus 7 here is positive. Minus into minus is plus. That's plus 49 by 16. Here also you will get 49 by 16 on both sides. So what we are doing, we will add this value 1 by 2 coefficient of x square. What is that? 7 by 4 whole square on both sides. See, here is x square minus 7 by 2x plus I will add here 7 by 4 whole square. It is that what I explained before in the beginning of this lecture, that is b by 2. B by 2. What is b? B is here 7 by 2. So 7 by 2 divided by 2, that is 7 by 4 whole square, is equal to minus 3 by 2 plus 7 by 2 whole square. Why we are adding on both sides? In order to balance the equation, so that the equation will remain same. Now see here, look at here. Here you have to remember one thing. Here we will use two formulas only here at this step always. Either a square minus 2ab plus b square equals to a minus b whole square, or a square plus 2ab plus b square equals to a plus b whole square. What is here? X square minus 7 by 2x plus 7 by 4 whole square. So it is a square minus, it's minus 2ab plus b square, that is equal to a minus b whole square. What is in place of a? That's x. Then minus 7 by 4 whole square, which is equal to minus 3 by 2. 7 7 are 49, 4 4 are 16. Understand this. Instead of these three terms, I am writing x minus 7 by 4 whole square. You should understand why I am not writing x plus 7 by 4 whole square. See here, in place of a in this formula, it is x. In place of b, it is what? 7 by 4. So here it is minus. That's why I am putting here minus. If it was plus, then I will put here plus. It depends upon this side, the coefficient of x, this term, the term containing the x, it depends on this. So you should understand this. Try to understand this formula, this identity we are using here, this identity. So we will get till here. Now x minus 7 by 4 whole square is equal to minus 3 by 2 was here before. So I will write here into 8 divide 8 plus 49 by 16. Why? Because I have to do here the addition. I will try to make the denominator same. Here 16 is the denominator. Here I will try to make the denominator 16. How? If I will multiply this 2 with 8, I will get 16. Since I am multiplying 8 to the denominator, I should multiply it to the numerator too. That's why I multiplied here above 8 and below 8. See here, x minus 7 by 4 whole square, it's as it is. No change in this step. I will not make any change. Now see here, 3 into 8, it is minus 24. 2 into 8 is 16 plus 49 by 16. It is as it is. Now I will take here, since denominators are same, so I will do the addition. Here subtraction will do I. So I will get here 25 by 16. Now see here, x minus 7 by 4. I want to remove this 2 whole square. Instead of this whole square, what I will do, I will take the root of this whole expression with the sign plus minus. With sign plus minus. Understand this. Omitting, removing, I need to remove this whole square. Instead of this, what I should do, if I will remove, I have to take the root of this whole expression, whole term, with plus minus sign. Then x minus 4 by 7 is equal to plus minus, this is root. Instead of 5 by 25 by 16, we can write 5 by 4 whole square, because 5 5 25, 4 4 16. Then square and root will cancel out. Now see here, this plus minus sign, that I will explain later after finishing this question, so that you will understand it better why we are taking the plus minus sign. Now see here, x is equal to, I will transpose this minus 7 by 4, it will become plus 7 by 4. Here I will transpose this minus 7 by 4, it will become plus 7 by 4. Then plus minus sign is there, 5 by 4 is there. Now see here, so x is equal to, since the denominator 4 is same, so I can write 7 plus minus 5 by 4. then I can write that is x is equal to 7 by 4, 7 plus 4 by 7 plus 5 by 4, and x is equal to 7 minus 5 by 4. That is, first I will take the plus sign, then I will take this negative minus sign. That's x is equal to 12 by 4 and x is equal to 2 by 4. 4 1 or 4, 4 3 or 12, and 2 1 or 2, 2 2 or 4. So at last we will get x is equal to 3 and 1 by 2 is the solution of equation by completing the square method. Here I will explain this plus minus, why we are writing plus minus with the root. See here, if we have x square equal to 1, this is a quadratic equation and it has two roots. That means x will have two values. Those values will satisfy the equation. If I will put x is equal to 1, let x is equal to 1, I will check whether it is a solution of the equation or not. So LHS is here x square, and in place of x I have to write 1. So 1 square is equal to 1 is equal to RHS. So LHS is equal to RHS. The 1 gets satisfied here. It means x is equal to 1 is one of the value of the solution of equation. Now if I will put x is equal to minus 1, see LHS is equal to x square. It means I will put here in place of x minus 1 and is equal to 1 which is equal to RHS. So this equation gets satisfied for x is equal to 1 and for x is equal to minus 1. These are the two roots of the equation. Now see here how I will solve this equation. X square is equal to 1. If I will write x is equal to root 1, then x will have only one value, that's x is equal to 1. This method is wrong. So what I need to do, x square is equal to 1, x is equal to plus minus root 1. That is x is equal to plus minus root 1 is 1. That's x is equal to plus 1 and is minus 1 is the solution of the equation. It is because of this square. It is because of this square we should take this plus minus sign along with the root, because it can be either plus value either minus value. You should understand this basic thing.